Today we're going to learn how to multiply rational expressions, and one of the things that you're going to have to be careful of is that you don't want to cancel right away. So in other words, on example 1 you can't cancel out the x's, or on this example you can't cancel out the x squareds first. So there's simply a two-step process to multiply these, and that two-step process is to factor first, and then if the same factor is on the top and the bottom, then you can cancel it. Okay. So let me show you an example 1 what I mean by factor. 20 goes into both 40 and 20, so we can factor that out. And if we factor out a 20, 20 times what is 40x? That would be a 2x. And 20 times what is a 20? That would be a plus 1. On the bottom example, you can see that 10 is common in both of those, so we'll factor out that 10. And again, 10 times what is 10x? That would be an x. And 10 times what is 30? That would be a plus 3. Now, in this part, the first thing is to factor. The second thing is to cancel if anything has a common factor. And 10 goes into 20 exactly 2 times. So we can cancel those, and final answer will be 2 times 2x plus 1 all over x plus 3. And fight the tendency to want to cancel out these x's. That's illegal. This is the final answer. In 1b, let's use this factor first. So we're going to have to remember how we factored in first semester. First semester we look at the factors of negative 15 that add up to a negative 2. When we did this first semester, we might scribble on the sidebar here, how do we multiply to be a negative 15? There's only 2 ways, and we're looking for adding up to the middle term, and if I take a negative 5 and a positive 3, I'll add up to a negative 2. So I factor this by putting an x and an x, a minus 5 and a plus 3. I can check that with FOIL. X squared minus 5x plus 3x is a negative 2x, and minus 5 times a plus 3 is a negative 15. Factoring in x squared minus 9, what are the factors of negative 9 that add up to nothing? Negative 3 and a positive 3. So that's your step 1. And then step 2 is if they're the same exact factor on the top and bottom, x plus 1 over x plus 1 equals 1, so you can get rid of those, and final answer will be whatever you're left with. And again, that will be your final answer. Can't cancel out the x's because the order of operations. So in example 2, let's factor first. So what are the factors of 16 that add up to negative 8? In the bottom, we're looking for what are the factors of negative 24 that add up to a positive 2. So if we write minus 4 and an x plus 6. Now again, the rule is simply this. If we have the same factor on the top and bottom, then we can cancel those. And why can we cancel it? Because anything over itself is equal to 1. So final simplification here would be x minus 4 over x plus 6. Number 2b is a little bit more difficult because we have a coefficient in front. So let's take care of that coefficient on front on the top. Both of these have a common factor of 2x, so we factor that out. 2x times what is a 2x squared? That will be an x. And 2x times what will give me a 10x? That'll be a plus 5. Factoring a 3x squared, we have to have 3x and an x to get a 3x squared. And you might remember we have to take the factors of 3 times a 5, which is a 15, that add up to the middle term, which is a 15 and a 1. But we don't just put 15 and 1 in here. These 15x and 1x are our multiplications. So 3x times a positive 5 will give me 15x, and an x times a plus 1 will give me a 1x. Now the rules are the same. If we have the same factor on the top and the bottom, we can get rid of those. The only thing left on the top is a 2x. The only thing left on the bottom is a 3x plus 1. And again, circle that, no further cancellation. Now the rules for multiplying, problems number 3 and 4 should look a little different. If we have all multiplication, what we want to do is rearrange. And what I mean by rearrange is we want to put all our numbers together, all of our x's together, all of our y's together. And then we will simplify. So again, look at example 1 and 2 and 3, how they're different. If we have multiplication in the whole problem, we want to rearrange and then we can simplify. So to simplify, we can see that 2 times 4 is 8, and 8 over 8 is 1. So we'd have a 7 as our number. Let's remember our rules of exponents. If we have x cubed and x to the 4th, we'll have an x to the 7th. But this is all over x to the 1st, so that'll give us an x to the 6th as our final answer. And here we have a y to the 1st and a y to the 4th. That would be a y to the 5th. And on the bottom we have a y cubed, so y to the 5th over y cubed would be a y squared. So our rules are different, and again, why are they different? Because the problems look different. So in example 4, we rearrange. When I say rearrange, we put our numbers together, our variables together, and we try to simplify. So take care of numbers first. 5 goes into 15 3 times. 3 times 3 is 9, and 9 goes into 27 3 times. Let's look at to see how many x's we have. We have 7 x's on the top and x to the 5th on the bottom. So we'll have an x squared left over. The y's, we have y cubed on the top. We actually have a y to the 5th on the bottom. So 3 and a 5 on the bottom. That would leave us with 2 more on the bottom. So I added example 5 because now example 5 is different than 3 and 4. So we've got to go back to the rules for 1 and 2, which are what? First you have to factor, then you can cancel. So let's factor part 1. They both have a 3 and an x common. So we'd have a 1 minus x for this factor. What are the factors of minus 5 that add up to a plus 4? That would be a plus 5 and a minus 1. Now let's factor the x squared plus x minus 20. We're looking for the factors of negative 20 that add up to a plus 1. That would be a plus 5 and a minus 4. And then we have a 3x on the bottom. And when you're looking at this, see this is all multiplication now. We're multiplying, 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 multiplying. So any term that's on the top that's exactly the same, we can cancel out. Why? Because x plus 5 over x plus 5 is 1. 3x over 3x is 1. So that leaves us with 1 minus x all over x minus 1. And if I factor out a negative 1 on the top, I'll get a negative 1 times a negative 1 is a positive 1, and a negative 1 plus x is a negative x. And now this might not look like the same, but let me just rearrange this. This is x minus 1 over x minus 1. Now we can cancel. Final answer equals a negative 1.